The previous contour toolpath demonstration was to show you how to use the chain command, but now I'm going to show you how to use the contour command without explanation how to use the chain. So before I do that, I still see my stock setup in here. I can turn it off by clicking here, the display. I can temporarily turn it off so that I can see my CAD model clearly, and I can apply now the contour. Because I'm using the entire rectangle, I'm going to use the chain. And again, I'm going to start from here because this arrow, everything on the left side of the arrow is the climb milling, so it will be cutting the outside. If I flip the arrow, it will be the climb milling will be the inside. So be careful when you choose your starting points, but you can actually fix it in here. So I say OK, and I get this window. In here the contour is already selected. We leave it alone because we started the contour, the cutting tool. MasterCAM has its own library, and if you see the library, I can show you all the tools. It has 446 different tools in here. And this exercise, I'm going to use none of them, or not none of them, but I'm going to unselect all of them. I'm going to use only the end mill. So I can select the end mills in here, say OK. These are the type of end mills available on MasterCAM. Now keep in mind that these numbers is the two numbers on MasterCAM. So I'm going to use a number 3/4 inch end mill. This number will be 294. Now if you did not choose the two settings in here that assign two numbers sequentially, you will get a number 294. But because you have the two number assigned sequentially, this tool, when you assigned it, it will become tool number 1. This is my first tool. This will be my tool number 1. And now you can also change it in here. If you want to change it to tool number 2, tool number 3, that's fine too. But it is easier for you to assign the tool automatically 1 and 2 and 3. Now in this setting, in tool setup, the stock setup allows you to assign the material. These numbers basically calculated based on the diameter of the tool and the material of the block. So in this case, I believe it was aluminum, so it automatically adjusts the cutting speed for me, the feed rate for me. Now the punch rate and the retract rate, you can actually modify it, and you should modify it depending on the operation. If this is not cutting, when the part is not cutting, coming down, when the going down motion, this is the down motion. When this coming down is not cutting, you can actually speed it up to 30 or 40. It doesn't matter, so that it speed up the machine time. But if this also the retract rate, this is going up. When it's done cutting, this machine, the cutting tool is going go up. So up motion, usually you do not have anything on the upper above the part. So when the CNC is complete, the tool goes up, so you can actually make it much faster. So we can make this setting higher in the punch rate and retract rate. But there are some exceptions, particularly when you are cutting into the parts. You will want to have slower RPM, the feed rate, like this one. But if you have a fixture that is blocking the sight, that you cannot see the upper motions, so you may want to go slower than you can see it. When you can assure that there's no the path is clear, then you can do a faster RPM retract rates. But let's leave it like this for now. Tool holder, it's not necessary to fix it unless you have a very complex drawing with complex fixture. You want to make sure the tool holder is not on its way to hit that the part or the fixture. Otherwise, in this example, I'm gonna leave it alone. And then the cut parameters. This is where you see the left and right. The left side is the climbing link, the right side is conventional. So I'm going to use it left side so that it based on what I selected in the previous when I do this chain. Tip and center point, because it's end point, the end mill, it does not have any problem with that. If this is a ball end mill, then you have to define this is the tip or the center. For flat end mill, you don't. For a drill, you do. And then in here, it is the stock to leave. We would like to leave the stock if this is a roughing tool. If this is cutting a rougher, you want to leave some material on the side or on the bottom so that you can go back to that material to finish it. You do not have to do that in CAD. Just do multiple lines, one for roughing, one for finishing. In here, MasterCAM will do that for you. So I'm going to leave 0 for now and treat everything as a final cut in my this demonstration. This 2D and 3D, because this is my 2D model, so the line is going to be straight. If this is a 3D lines, then it will follow the curve. And then the next one, depth cuts. In this example, I'm going to use one cut. I'm not going to change it. In the future example, you will see how to adjust this. So you can have multiple cuts in here in one setting. Lead in and lead out actually is very important. Lead in and lead out is the one allowing you to have the tool leave the part a little bit distant and then slowly approach to the part, and then it cuts. Now, for example, if the tool comes here, it goes here and then slowly and cut this portion and leave the parts. But if you don't do that, the tool will go right in and punch the material and cut it and leave right there. And by doing that, either you crash into the parts, or you kill the tool, or you leave marks on the parts. So having lead in and lead out is a good thing to do, and you just have to make sure it's not on its way hitting some of the fixture or the pins on the side. So we leave that the same, and you actually can adjust how much it lead in and lead out. So you can go this far closer from the parts. You can go from here, lead in, lead out, or from here, lead in, lead out. So you can adjust the distance in here. Breakthrough, because we are using, I can adjust the parameter later. But if you don't do that, you can say, all right, breakthrough, make sure that material go that far, this much further down. That's the breakthrough. But for these examples, I'm going to skip it. Multi-passes, you can use the single CAD file, this rectangle for example, or this square. You can have the same square and have multiple toolpaths around it by setting these multi-passes. You can have one that's 1 inch away, and then half an inch away, and then a 1/4 inch away. Just keep on cutting it. So what happens is when you have a block that's so big, you have to have multi-cuts. You don't have to create drawings, different drawings, offset drawings to cut roughing cuts. Second one is another one, and another one. You can just do that all in this setting. But in this example, I'm going to leave it unchecked just because I do not have to do the multi-pass. It's one final cut. Tab, I'm going to skip that for now. Link parameter, that's where the major setting in here. Remember, we have the clearance plane, retract plane, and the feed plane. So these are the setting in here in this two setups. So we want to override it so that we can actually adjust this number. What it will do is to have the tool coming in, let's say this one, clearance. So you can allow the tool rapidly come down to this distance. And then you can check, okay, it's clear, allowing you to go down to the feed plane, come down rapidly to this feed plane. And then you still check, okay, it's good. Now you can slowly go down into the depth of the material. And similarly, when you are done with the cutting, you can go back to the feed plane. And then when you're done with the feed plane, when you finish the cutting, and that's where the retract is, and you can make it fast going up. So remember the previous setting, the retract was a low number in here. This retract, I increased it just because this portion is not really cutting. I'm going much faster to move to a different distance. So your retract, you can go higher. You can adjust this number as well. So clearance, make it 2 inch so that you know it's coming down, it's not crashing to the part. Just give you some safety distance. And retract, when you are done, you can go fast or go slow or higher. You can go make it 0.5, go higher so that you are away, or 1 inch, you are really away from the part when you're done. Feed plane, it can be as closer to the part as you can, because you don't want to have this distance. You don't want to have 1 inch in this distance, because if you go 2 inch per minute, 3 inch per minute, that itself is 1 inch. That will be 1 minute already. So you were watching that. That will cost too much for the machine to run. So that usually is like a very small distance, 0.2. Some people use 0.1. The stock, the top of the stock, you can actually say this is 0, or this is 0. So it really doesn't matter. You have to, when you do your programming in your parts. I will give you an example. In my case, my top of the stock is 0 in this drawing. So the tool will go into this here, the 0. Now the depth of cut, I want to go it down. So remember, I have 1 inch. Now keep in mind that I have a vise holding it. I have a vise holding it. The block is 1 inch. I have a vise holding it. So I cannot go anything more than 1 inch. And I do have to have some distance for it to clamp. So I cannot go more than, let's say, 0.75. This will be my cutting distance. It actually is negative 0.75 because this is positive 0. So I say OK. So you will see this is the toolpath that comes down, go around, negative 275, go up. Now this is where the lead in, lead out comes in. And also there's a setting called round the radius. You can round the corners in here. Now let's go back to the parameters. I'm going to turn this off for now. And see this sharp corner, a rounded corner? If I say none in the cut parameter, this corner will be gone. This corner will be gone. Like it will not be rounded. And right now I turn off the lead in, lead out. You can see that. And because I recreate the toolpath, I have to regenerate the toolpath. So I'm going to regenerate it. Now this is my toolpath. And my toolpath, if you look at it, it starts from this point, punch down. Now think about it. If I have material here, I have some material so that I can cut, right? So if this point comes down, punch it, it most likely will hit that material and will hit the tool rapidly. So that's for this reason, it's important to have lead in, lead out. I'm going to regenerate it again. So coming in, so it will not punch the material, it will coming from the outside of the material slowly and then cut it. Now that is the first toolpath that we teach in here is a contour.